Kennedy, you're welcome. You're welcome. You're welcome. Welcome to the channel. Please call your friends to also join us for the live section. Call your friends also to join us for this live section. You are welcome. 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 So for this question, we have these question: find an equation of the tangents, and the normal at the points where x is 2 in the curve, with equation y equal to 8 over x minus x plus 3x squared. And we are told that x is positive, is greater than 0. Okay? So that's what we have there. As you are coming in, just begin to say I. Okay? If you are here for the first time, please subscribe to the channel. Okay? Thank you for doing that. So this one is okay. So let's go to the solution to the question. The first thing we are going to do there, we are given x is equal to 2. We have the s coordinates. So we need to find the y coordinates. We need to find the y coordinates. We have x equal to 2. So we need to find the y coordinates. Okay. So what we're going to do now is to go to the equation. When x is 2, y will be equal to 8 over 2. That's a 4 minus 2 plus 3 times x squared. And that will be what? That's a 4. 2 squared is 4. So we're going to have 4 minus 2. That's a 2. And then plus what? Plus 12. And that's what? That's 14. So we're having 2, 14 as the coordinate points. 2, 14 as the coordinate points. Okay? So then the next thing to do now is to get the gradient or the slope, which is the y and the x. That's the differential coefficient. Okay. So for us to do this one, it's more better to write the equation in this form: 8 times x to the power minus 1 minus x plus 3x squared. Okay. And that will be equal to what? We're going to have this power will go to the front, and that will be minus 8, and then times x power minus 2. The power minus 1, making minus 2. If you differentiate this one, that will be minus 1, and this will be what? 2, these 2 times will come to the front. That's what? That's a plus 6, and then the power minus 1. So that's a power 1. So that's what we have for the gradients. So we need to find the gradients at x equal to 2. So this will be equal to what? Minus 8. You can break this one down. Okay, that's what? That's okay, let's solve this algebra first. This will be equal to this one will be equal to minus 8 over x squared. Okay, this minus is 1 over x to the power 2. So minus 1 plus 6x. Then you can now make your substitution. So which will be equal to what? Minus 8, 2 squared, that's a 4, minus 1 plus 12. 6 times 2, that's a 12. So we're having minus 2 minus 1 plus 12. So that's equal to what? Minus 3 plus 12. That's what? That's 9. So we have 9 for the gradients at x equal to 2. Our gradient is what? Is 9 at x equal to 2. Okay. If you have your own question, please type it at the comment section. Okay. If you have any question on these C1, just put it on the comment section and then we'll solve it together. Okay. If you are coming in for the first time, just say I. Okay. Say I. If you are yet to subscribe, do that right now. What to do now is to we've gotten the gradients as 9. Then we've gotten the coordinate points 2, 14. Then equation of tangents. Equation of tangents. Equation of tangents is y minus y1 equal to m times x minus x1. Okay, that's the equation of tangents. Okay, so we have to find equations of tangents and the normal. Okay, equation of tangent will be equal to equation of tangent is y minus y1. My y1 is 14 equal to my gradient is 9 times x minus what? X minus x1. That's a 2. You can do the expansion. 9 times x, that's 9x. 9 times 2, that's minus 18. Okay, then you can make your y the subject. That will be 9x minus 18 plus 14. And that's giving us 9x minus 4. So that's the equation of the tangents. Equation of the tangents. Okay, so the next thing to do now is to get the equation of the normal. Okay, I'm going to divide this section to 2. We'll do the first part, we'll take rest, then we'll come back again. Then another episode will be integration. Okay, so we're going to have 2 more sections this night. Okay, so as you're coming in, just begin to say I. So then the next thing to do for the equations of normal, we need to get the gradient of the normal. Which is equal to what? Which will be equal to minus 1 over the first one we got, that's 9. So equation of normal will be equal to y minus y1 over minus 1 over m times x minus x1. Okay, actually the foundation of this one has been laid. So if you miss the first part of this section, please watch the finding, check it on the channel for finding equations of how to find equations of tangents and the normal. The foundation has been laid. We spent almost an hour, okay, 2 days ago. Okay, so check that for the foundation. This is just the continuation. Okay, so this is what we have for the equations of normal. Okay, let's just plug in what we have. My y1 is what? My y1 is 2, 2,14 equal to minus 1 over 9 times x minus 2. Okay, so that's what we have. Just tidy things up, do the expansion, make y the subject, so that will be minus. Okay, what we can do in this case is to multiply this by 9 so as to cancel the fraction here. This place also times 9, so that will be 9y. Okay, 9y. So that's just that. Just solve that. Make y the subjects. Make y the subjects. Make y the subjects. So as I was saying, if you multiply it by 9, so that will be 9y. 9 times 14, give us the value. 14 times 9, so that's 36. That's 12. 1, 2, 6. Okay, minus 1 times x, that's minus x. Minus 1 times minus 2, Oh, there's plus 2. This 9 and this 9 we cancel. So you can move everything to the other side. So you have 9y plus x minus 126 minus 2 equal to 0. So that will be 9y plus x minus 128 equal to 0. So that's what we have for the equations of normal. So let's take one more questions, then we'll take a break, and then we continue again. So let's take one more questions. So that's the equations of normal and equations of the tangents. Okay. For those that missed the Saturday live section, I will quickly do the recap now. I will do the recap for equations of tangents and normal. Thank you for coming on board. Thank you for coming on board. So let me quickly review what we did on 2 days ago. Let's recap that. Then we'll take questions. What we said about equations of tangents. Equations of tangents. Equations of tangents is this equation using the point slope form, where the m is the gradient or the slope, and then we are using calculus to get the slope, which is the y, the x. Okay, the x1, y1 are the coordinate points, the coordinate points. Okay, so if one is given, okay, then you go to the original equation and plug in that point and get the second point, because the coordinate must complete. It must be x and y. Okay, it must be x and y. So once you've gotten that, then you make your substitutions and get the equations of a tangents. And if you don't want to use this equation, you can as well use this one, the intersect slope intersect form. You can use this one. You can use this one as well. You get the same answer. So the choice is yours to determine whether you want to use this one or you want to use this one. So these are the things we discussed. So this is another question we have. The normal to the curve 2y equal to 3x squared. 3x squared minus 7x squared plus 4x at the point O. Okay, and that point is 0, 0. Okay, meet at point N. Okay, the normals, they meet at point N. Find the coordinates of N. That's the A part. B, calculate the area of triangle OAN. Okay, so that's the question we have. Please, as you're coming in, just begin to say I. Okay, let's look at the comment section. So this is what we have, the normals to the curve. Okay, so we need to find the gradient first. So we're going to make y the subject. Okay, make y the subject by dividing the equation by 2. The left side by 2, the right side by 2. So that will be 3 by 2 x cubed minus 7 over 2 x squared, and then plus 2x. So that's the first thing to do. Okay, then we can find the y dx. Find the y dx, and that will be equal to this 3 will go to the front. That will be 3 x squared Okay, and then minus these two also will go to the front. That will be 7x. That's 7x, and then plus what? Plus 2. So that's the gradients. That's the gradients. Okay. Little adjustments. This will be if 3 go to the front. If these 3 go to the front, that will be 9 over 2. That will be 9 over 2 x squared. These 3 go to the front, and this power minus 1. Okay. This one also go to the front, and that will be what? That will be 7x, and then the power also minus 1, making power 1, and then 2x. That's 2. So that's the gradient for that one. Okay. So at point O, at point O, x is equal to 0. So the gradient is what? Is that 2. The gradient is 2. Okay. Sorry, the question is not complete. The question is not complete. They're going to make adjustment to that. The question is not complete. So we have. So begin to give your comments to this question at the comment section. Begin to put your answer at the comment section for this question. So when we come back, we're going to look into it detail. Well, right now, begin to put your comments at the comment section. Okay, so we have 2 more sections. We're going to continue this one, and we're going to start integration this night. Okay, if you're yet to subscribe, please do so right now. Okay, see you shortly for the continuation of this one.